welcome to screencast on the blast furnace, which is all to do with the extraction of iron from iron ore. What I'm going to do is show you an animation which I'm going to talk through, and then I'll talk through the 5 different chemical reactions that we went through in class which occur in the blast furnace. Okay, so hopefully this screencast will be able to help you answer the questions on the worksheet I asked you to do for prep. So extraction of iron. First thing is the extraction of iron happens in a thing called a blast furnace. Very simply, a blast furnace is a big long tower which is lined with heat resistant bricks. Okay, so you'll find heat resistant bricks lining this big long tower. At the bottom of the tower we have inlets which we can pump hot air into, hence the blast. A blast of hot air is pumped into there, and the oxygen which is in the air is involved in one of the chemical reactions which causes the heat to increase inside the blast furnace. Anyway, what we're going to do is break down this process into a number of steps. So let's deal with step 1. Step 1 involves adding 3 raw materials into the top of our blast furnace. The 3 raw materials are iron oxide, okay, which is sometimes known as iron ore or hematite, but be mindful of that we don't get pure iron ore, pure iron oxide, in that the iron oxide will have impurities of rock and sand, etc., or silicon dioxide in it. Okay, so that's one of the raw materials that we add into the top of the blast furnace. The second is limestone or calcium carbonate. Okay, is the second raw material that we add to the top of the blast furnace. And the third is coke or just pure carbon. Okay, so the step 1 is we simply add these to the top of our blast furnace. In they go to the top of the blast furnace. So that's step 1, very simply. Step 2 involves hot air being blown into the bottom of the blast furnace, which then reacts with the coke in an exothermic reaction, i.e. giving out heat, to form carbon dioxide. So the orange thing at the bottom is to show the oxygen being blown in, causing this fire which produces lots of heat, an exothermic reaction. And then the little comment box to the right shows our carbon, which is the coke, reacting, watching it react with the oxygen atom to form carbon dioxide, carbon bound with 2 oxygens. Okay, so that is step 2. That's followed, funnily enough, by step 3, and step 3 involves the heat which is produced by step 1, because it's an exothermic reaction, causing the decomposition of the limestone. Now, limestone is calcium carbonate, and it decomposes into something called calcium oxide, or sometimes known as lime, and carbon dioxide. So the limestone, okay, so if you look at the comment box to the right, you can see calcium carbonate, calcium being the positively charged ion, which is ionically bound to a carbonate ion, which is CO3. Now what happens when you heat that is the carbonate ion breaks down into a carbon dioxide molecule, which is then given off as a gas, and leaves an oxide ion behind. There we go. So there's, you can see the carbon dioxide, okay, the carbon bound to the 2 oxygens there on the right, and now we've got an oxide which is now bound ionically to the calcium. Okay, so That's the decomposition of limestone. Okay, and both the carbon dioxide and the calcium oxide are important in later stages in the blast furnace. So the next step step 4 involves the carbon dioxide, which we've just produced in step 3, plus the carbon dioxide that we also produced in the second step, now reacts with more coke, more carbon in the blast furnace to produce a gas called carbon monoxide. Now this process is endothermic, requires heat energy, because the carbon dioxide is reduced to carbon monoxide. It's a reduction reaction, so it needs heat energy. So the heat that was produced in step 2 is very important for this endothermic process. So the carbon reacts with the carbon dioxide to produce 2 molecules of carbon monoxide. Carbon monoxide being 1 carbon bound covalently to 1 oxygen. So carbon monoxide is now involved in the next step, which is step. So the next step is step 5. So here are step 5, which involves the carbon monoxide that we just made in step 4. Here's carbon monoxide. We need 3 molecules of this to reduce our iron oxide. Okay, so iron oxide is Fe2O3, so 2 iron ions covalently bonded to 3 oxide ions, and a chemical reaction occurs where the carbon monoxide reduces this to iron and produces carbon dioxide. So let's just watch that. So here we go. Here's the 2 ions and the 3 oxygens below and the 3 carbon monoxides. So what happens is that the 3 carbon monoxides then react with each of these oxygens, 1, 2, 3, okay, to make carbon dioxide, leaving the iron on its own. Okay, so the iron oxide is reduced, oxygen has been removed from it to produce metallic iron. The next thing that happens is that just going back a little bit, next thing that happens is that the iron which has been made melts, becomes liquid and sinks to the bottom, okay, and can then flow out the bottom of the blast furnace. Now, the next step is quite complicated in that what happens is that we now need to think about some of the waste products, the impurities we talked about that exist in the iron ore. Okay, so our silicon dioxide, if silicon dioxide was left in the molten iron, it would cause all sorts of problems with the iron, make it brittle, and so what we need to do is to try to get rid of some of this silicon dioxide, and that's where the lime comes in. Okay, so remember we made lime in step 3 by breaking down limestone, okay, to produce calcium oxide, which is lime. Now what happens here is that the lime reacts with the silicon dioxide to produce calcium silicate, okay, which is more commonly known as slag. And what happens to the slag is the slag then forms a molten slag which sinks to the bottom of the blast furnace, okay, but it's less dense than the molten iron, so it floats on top of the molten iron, and that too can be runs off the bottom of the blast furnace. Okay. And then lastly, the iron that we run off the bottom of the blast furnace is it's now called cast iron. It's not entirely pure, and it's got lots of carbon from the coke still as an impurity, and we have to treat that later, which I'll tell you about on a further lesson. Okay, so just to summarise all of that, okay, what we were talking about. Okay, so the first thing is that we have 3 raw materials that we add to the top of the blast furnace. Iron ore, which is essentially iron oxide, which is Fe2O3, sometimes known as hematite. We have coke, okay, which is carbon, symbol C, and then limestone, which is calcium carbonate. So these are the three things that we add to the top of the blast furnace. So that's step 1, adding those 3 raw materials to the blast furnace. Step 2 is the coke, which we had from our step 1, which we added to the top of the blast furnace, reacts with the hot air, the oxygen in the hot air that we blast into the bottom of the blast furnace, and that produces carbon dioxide. Okay, so that's the word equation for that. That's the symbol equation for that. Carbon plus oxygen forms carbon dioxide. The next step, step 3, involves calcium carbonate being heated up with a high temperature caused by this exothermic reaction here, and that decomposes, a thermal decomposition, into calcium oxide and carbon dioxide. Again, the symbol equation here, CaCO3 forms CaO plus CO2. And then step 4 involves carbon dioxide, which is produced from this reaction and this reaction, reacting with more carbon, okay, in an endothermic process to produce molecules of carbon monoxide. Okay, and the carbon monoxide is important because that is the substance which is going to reduce our iron oxide, which is the next step, step 5. So this shows carbon monoxide reacting with iron oxide to form iron plus carbon dioxide. So here's the word equation, carbon oxide plus iron oxide forms iron and carbon dioxide. Here's the balance symbol equation, 3 carbon monoxides plus 1 of iron oxide forms 2 lots of iron and 3 lots of carbon dioxide. Okay. Now the next bit is slightly more difficult to understand. The calcium oxide, which we produced in this reaction here, okay, which is sometimes known as lime, now reacts with some of the impurities in the iron ore, which is an important part of the whole process. Okay, so our calcium oxide here, calcium oxide reacts with the sand and rock, which is silicon dioxide, in our iron ore, our impure iron ore, and produces a substance called calcium silicate, okay, which is more commonly known as slag. Okay, and the slag melts and sinks to the bottom of the blast furnace, but it's less dense than the iron, so it floats on top of the iron, which previously had sunk to the bottom of the blast furnace, and can be extracted from the bottom of the blast furnace. Okay, so hopefully that animation and that little screencast should help you with that worksheet I asked you to do for prep.